I've got quite an interesting repair job to do here. It's off a Elliott Progress drill press. It's actually a spindle. Got splines in there, and that's what the driven shaft comes down. This bit's driven by the motor. There's a bearing top and bottom, and there's 2 oil seals going there, and it's actually submerged in oil. I don't know what's actually happened though, but someone's obviously managed to totally destroy the end of it. Of course, the oil seal's been trying to run on there, it's just been at the oil seal. The bit where the bearing fits is still good. You can feel a slight lip there, so that part there is still good. The same as that size there, that's 2 bearings, 1 each end. What I've got to do is try and repair this and get a good surface for the oil seals to run on. I think what I'll do, I'll turn a stainless steel plug to fit in there and weld it up, weld into the plug as well, and then bore it back out to size, and then machine the outside diameter to a good finish, the correct size, so the oil seals can run on it. The material it's made out of, it's hard, but it's not stupid hard. It's been hardened. I will use stainless steel to repair it with. I like using stainless steel as a material for a weld build-up. There's a little bit of damage on there, but I don't think that will be affecting anything. And I intend leaving the part where the bearing fits well alone. Just weld that bit up. There's a nick there, like a grinder nick to weld up, and that bit there. I'll clean it up, make a plug for it, and go about welding it. You see the damage there, and obviously the damage is done to the oil seal. It's just had no chance. Obviously you can't get one of these that completely obsolete now, but are a good drill, and it is well worth fixing. I've got a piece of suitable stainless bar. As is normal, we'll face the end first, turn it down to size and part the piece off. Just to give the weld something to back onto it. All put in, one more cut on the same setting. Right, that's quite nice. I think I'll just make it a little bit longer. Put a chamfer on, then part the piece off. Some nasty swarf comes off, stainless. The parting tool is on centre height. I just need to make sure it's square at the job. The easiest way is just to square the tool holder up under the job like that. Tool holder's touching the chuck there, which means the tool has got to be at 90 degrees to the job. This is fairly small diameter stuff, so I'm going to part it off quite quickly. By quickly I mean a quick surface speed. see in this shot I'm going to use a new camera mount that we did last week. All I want to do is file the rough edges just to make sure that there's no oil in there. Oil and welding does not mix. Bastard. Try not to use a grinding wheel on this, because even using a grinding wheel can contaminate the metal, and that can cause problems when you come to weld it. You have a file or a rotary burr. See, this is hard, being hardened, but it's not ridiculously hard. It doesn't need to be. It could well be hardened further up where the splines run. It's not, soft all the same. Okay, so that's like that, and the plug will fit in there, and I can weld up around there, build it up with weld, and hopefully remachine it back to size. I still haven't got round to sorting the filter out for the camera to stop the glare on the clock gauge, but I'm sure you can see it there. We need to get this running true, not somewhere near, it's got to be true as normal, high point. The sort of readings is given, I don't think it's completely wrong, which is possible because welding can distort things in strange ways. It's within half a thou, but it's not as good as I would like it. Like I say, I don't think it's round anymore. I think it's got a very slight ovality to it. For an oil seal to run on a half thou run out nothing. Right, we'll try a cut on it that and see what it cleans up like. I haven't put enough build up metal on here. It wants building up some more, and where I'm getting close to the original metal there, it is really hard. That may even need grinding. That putting a decent finish on, but I'll need to weld this up some more, build that up quite a bit more. I'll weld it up in the lathe. I'll just put a good earth onto the chuck and do it in the lathe. I've put some more weld metal onto it. I've also changed the tool. I've put a tool in here which should stand up, not interrupt and cut much better. The weld material is actually machining quite nicely. I think that when it gets down to the alloy of the stainless and the base metal, that's when it becomes horrible and hard. This is where the tool post right now would be useful. There is ways around it, there is ways of using it. Die grinder. see how we'll get on. That is really hard, that. Try to cut across the face now, just for a laugh. That's cutting fine because that's just putting stainless there. Right, so now we can machine that face up. This is the bastard, this hard bit here. And these bits here, once I get this down to size, I'll fill them up with brass. I'm not going to weld on it anymore. I'm beginning to wish I'd never seen the thing now. I've persevered with this and I've given it a clean up with some emery and it's not too bad. The bits that are good are really good, but I've still got these little blow holes here that will just destroy the seal. I'm reluctant to try putting any more TIG weld on here. I may try putting some silicon bronze on. Yeah, I've put some silicon bronze onto the two bad bits. Hopefully this will turn off a lot easier. Could be getting somewhere now. There's a mark there I didn't weld up, but I don't think that would be on the oil seal. I'll take a bit more of it. Just cleaned up quite nicely now. I really wish I'd used silicon bronze instead of stainless to weld it up. See where the brass, where the bronze has gone into the imperfections. There's a one there, little one there, and that's the only really bad one, and the bearing goes to there, so I think the two seals will probably miss that. I'm undecided whether to have a go at brazing that one up as well or not. If I could actually machine this down, I would take it all down and braze the whole thing up and remachine it, but it's just too hard. I think I'll try and get that bit there. Right, I managed to weld up the two areas that were down. I've learnt one thing doing this job. Those silicon bronze rods are really good. I'll machine that off, polish it up, then I think I'm going to be pretty well good to go. Right, I've had a good bit polishing it. I'm quite happy with that now. Slightly undersized for the bearing, but I haven't touched the part that the bearing fits onto. And that's the oil seal, and that's got a good grip on there. There's two seals in there, and I think I'd be tempted now to leave it well alone. Certainly no more weld build up on it. It's annoying because the bits that are good in here is really good. I just wish I'd brazed it or silicon bronze welded it instead of putting stainless in. Now I'm going to bore the centre out to regain the original internal diameter. So I throw the stainless, plug it or weld it in. Now it's time for a boring bar. Into the weld material now. And we're just about there. You shouldn't put your fingers into holes like that, especially when the bastard things are hot. You can actually see the, quite interesting, you can see the weld metal has a little thin, very thin shell of stainless left. I think one more cut will have it done. So I can get the camera in so you can see that a little bit better. That's quite interesting. And hopefully you can see where that's weld metal there. I'll put one more light cut through it. Right, I'm going to call that done. Oh, that's done. It's gripping the seal nicely, and there's two seals on there. That is slightly undersized, but I've still left to learn where the bearing fits. It's certainly not better than it was when I first started with it. As I've already said, I've learned quite a lot. I've learned a lot about bronze welding, and I certainly like it. For the shaft build up where oil seal runs, even where a bearing runs, I can't see that being a problem, and it's a lorry's at the machine. You TIG welding stainless onto that, created some wonderful alloy that's as hard as the hobs of hell. Once again, it just remains to say, thanks for watching, thanks for subscribing, and as always, a massive thanks to all the well wishers that are coming in towards my wife Deb and my dad. That's still coming in. I'm getting emails daily. Fantastic, it really is. Thanks very much.